This apparatus enables you to generate pure energy from mere household food refuse. Nevertheless, in numerous American localities, its operation is technically prohibited. This is a domestic biodigester. It transforms 5 pounds of food waste into 2 hours of cooking fuel, prevents methane from entering the atmosphere, and can be constructed for under $200 using items from your neighbourhood hardware store. What you are about to learn is about a biological refinery that the energy corporations wish to keep from your knowledge, its mechanisms, and the regulatory frameworks that hinder its utilisation. For millennia, individuals across Europe and Asia reported witnessing peculiar, flickering lights hovering above wetlands and burial grounds at night. They referred to them as will-o'-the-wisps or spectral candles, and in local legends they were believed to be spirits leading travellers astray. However, what they were actually observing was the initial indication of a biological power generation system. Those lights were pockets of methane gas produced by decaying organic matter beneath the water, spontaneously igniting upon contact with the air at the surface. The definitive scientific examination of this phantom illumination commenced in 1808. It was at that juncture that the chemist Sir Humphrey Davy conducted a series of controlled trials, establishing that the gas emitted from the fermentation of organic material was indeed methane. By 1859, a community in Bombay, India, took this laboratory-scale discovery and transformed it into operational infrastructure. They erected the initial documented large-scale anaerobic digester, utilising the facility's refuse to supply all the illumination and cooking fuel for the entire populace. This was not a casual endeavour. It was a functional public service that did not necessitate drilling, hydraulic fracturing, or thousands of miles of steel piping. As the Industrial Revolution gained momentum, European engineers began to perceive wastewater not as a disposable byproduct, but as a valuable resource. By 1895, the city of Exeter in the United Kingdom was illuminating its public thoroughfares with gas recovered from its own sewage network. During the Second World War, when fossil fuels were redirected to the war effort, thousands of European farmers persevered by converting their tractors and domestic stoves to operate on biogas derived from manure containment areas. The reason a biodigester surpasses all other sustainable waste management solutions is not rooted in mechanical power. It is based on the fundamental principles of anaerobic digestion. To comprehend how a container of kitchen scraps becomes a blue flame on your stovetop, one must delve into the biological processes involved. A biodigester functions as an artificial digestive system, a sealed, oxygen-deprived enclosure where a specialized microbial consortium, known as methanogens, deconstructs organic material. Consider it a living mechanism that processes what you cannot. And this decomposition occurs in 4 distinct biochemical phases. The first is hydrolysis, where complex compounds such as proteins and lipids are broken down into simpler sugars. Subsequently, acetogenesis and acetogenesis take place, where another bacterial community converts those sugars into organic acids, effectively transforming the refuse into a biological slurry. Finally, the methanogens assume control. They metabolize those acids and, in doing so, release a gas mixture comprising typically 60% to 70% methane. Because methane is less dense than air, it ascends to the upper portion of the tank. The pressure generated by the gas itself, typically measured at approximately 0.15 to 0.3 pounds per square inch, is sufficient to propel the fuel through a half-inch conduit directly to your kitchen range. It requires no compressor, no fuel pump, and no external power source. It is a self-pressurizing energy source. However, the most significant benefit lies in the residual material. In a conventional composting system, as much as 50% of the nitrogen
dissipates into the atmosphere as the material decomposes.
Conversely, a study published in the journal Waste Management in 2012 demonstrated that anaerobic digestion operates within a closed system, retaining nearly 100% of the nitrogen, phosphorus, and potassium. For every pound of discarded food you introduce, you obtain 0.9 pounds of bioslurry, a high-quality liquid fertilizer. The biodigester is not merely a domestic energy producer, but also a nutrient reclamation device that converts your kitchen discards into superior garden nourishment available. In 2024, investigators studying residential biogas systems in moderate climates discovered that a standard 212 cubic foot digester, approximately the size of 2 large refrigeration units, could generate ample gas to prepare 3 complete meals daily for a family of 4, utilizing solely their organic refuse. The data reveals an impressive 1-to-1 efficiency ratio. According to research from the Food and Agriculture Organization of the United Nations, for every 2.2 pounds of food waste introduced into a properly maintained system, you can anticipate collecting approximately 14 cubic feet of biogas. And in an average American household, which discards an estimated 200 pounds of food waste per individual annually, a single family is discarding sufficient energy to fulfill up to 30% of their cooking fuel requirements. Regarding carbon emissions and environmental sustainability, the comparison is overwhelmingly in favour of biodigesters. A report by the Environmental Protection Agency confirmed that methane is 25 times more potent as a greenhouse gas than carbon dioxide. When food waste decomposes in a landfill, it generates methane that escapes into the atmosphere. By capturing that methane within a biodigester and combusting it, you establish a mutually beneficial outcome. You prevent a potent atmospheric pollutant from being released, while simultaneously displacing the fossil fuel methane that would otherwise be extracted and transported to your residence. Furthermore, consider the pathogen control aspect. Research conducted by the International Renewable Energy Agency has indicated that the anaerobic environment and the intense microbial competition within the tank substantially reduce the presence of E. coli and other detrimental bacteria. Given the ease with which a biodigester can be implemented and the degree of self-reliance it offers, one might question why it has not achieved wider adoption. The concise explanation involves the National Board of Fire Underwriters and local zoning authorities. The current regulatory framework that excludes biodigesters from American suburban settings is a composite of fire safety codes and regulations addressing public nuisances. Because the natural gas industry seeks to portray methane as a high-pressure hazardous substance, they have influenced building codes to classify a low-pressure biodigester as if it were a commercial chemical facility. In reality, the internal pressure within a domestic digester is less than 0.5 pounds per square inch. For perspective, a standard propane cylinder used for backyard grilling operates at approximately 100 to 200 pounds per square inch. A home digester presents a hazard thousands of times less likely to cause a structural explosion than the industry standard propane grill situated on your patio at this moment. Then there is the disparity in financial incentives. If every household in a county produced 50% of its own cooking gas, the multi-billion-dollar natural gas utilities would experience a significant decline in revenue. There is no commercial motivation for a utility provider to advocate for a technology that transforms a homeowner into a competitor. In many United States jurisdictions, the model biogas zoning ordinances were specifically drafted for large agricultural operations housing 10,000 head of cattle. They mandate costly environmental impact assessments and professional engineering certifications, which can amount to $10,000 before even acquiring a tank. These regulations were not conceived to safeguard the public. They were designed to ensure that the threshold for entry remains prohibitively high for the average individual. However, if you aspire to construct your own biological refinery, here is the essential information. For the majority of individuals, the initial step involves pre-engineered home systems, such as those manufactured by Home Biogas. These are assembly kits that include a flexible digestion bag and a specialized cooking appliance.
A typical unit is priced between $700 and $900. If you reside in a warmer climate, this system requires minimal attention and typically recoups its cost through savings on gas and fertilizer in under 3 years. For the budget-conscious homesteader, the IBC tote design represents the global benchmark for do-it-yourself biogas systems. Utilizing a standard 275-gallon plastic water container, you can assemble a fully operational digester for less than $200. The critical element of this construction is the watertight seal. It is imperative to ensure that both the waste inlet and the effluent outlet are submerged within the liquid to preclude oxygen from entering the tank. This is a singular rule that cannot be violated. If oxygen infiltrates, the methanogens perish and the system ceases to function.
The open-source instructional materials provided by the Solar Cities project serve as the premier technical resource, offering precise plumbing specifications. Now, if you reside in a colder region, the primary obstacle is ambient temperature. When the tank's temperature drops below 68 degrees Fahrenheit, the bacteria become inactive. The innovative solution, pioneered by researchers at Thomas Jefferson University, involves integrating your biodigester with a greenhouse or a solar thermal heating circuit. By maintaining the necessary mesophilic temperatures, you can produce gas even during a Canadian winter. Maintenance is the final component of the process. Given the absence of any moving parts, the maintenance is exclusively biological. You must regularly supply nourishment to the system, and you must manage the pH balance. If you introduce an excessive amount of acidic material, such as a large quantity of lemons, the digestive environment becomes too acidic, and gas production halts. Resolving this issue is straightforward. Add a measure of wood ash or baking soda. Both substances act as antacids, rectifying the chemical balance. The domestic biodigester represents a 150-year-old solution to a 21st century challenge. It is a system founded on a singular observational principle of nature. There is no such thing as waste. There is only energy that has been misplaced. If you permit this biological process to operate, it will transform your kitchen discards into a silent, self-regulating flow of fuel, independent of the electrical grid, utility companies, or the series of failures that characterize contemporary landfill operations. Much of the content featured on this platform was nearly lost, not due to its ineffectiveness, but because the industry deemed simplicity and self-reliance to be unprofitable. If the rediscovery of the lost practice of self-sufficiency is important to you, then subscribing and sharing this content is the most straightforward way to ensure such knowledge continues to be disseminated. In this video, we explored the biodigester, which converts waste into fuel. However, if you are interested in observing what transpires when this same closed-loop principle is applied to a system that heats your residence utilizing solely ambient air and a few repurposed cans, then you should proceed to view our video on the soda can heater next.